Astronomers tracking 3I Atlas say it has altered its course, worrying scientists about its close proximity to Earth.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live.
On July 1st, 2025, the skywatching world was captivated by the discovery of 3I Atlas, the third confirmed interstellar object ever detected passing through our solar system. Found by the Asteroid Terrestrial Impact Last Alert System, Atlas telescope in Chile, 3I Atlas immediately grabbed attention not only for its origins beyond our solar system, but also for its unusual behavior. Unlike the countless asteroids and comets native to our solar system with predictable orbits, 3I Atlas travels on a hyperbolic trajectory at a remarkable speed of around 58 kilometers per second relative to the Sun, which will carry it through and away from our neighborhood forever. This fast, unbound orbit confirms an interstellar origin, possibly from another star system in our Milky Way galaxy. Since its discovery at approximately 4.5 astronomical units, AU, from the Sun, over 670 million kilometers away, astronomers have actively monitored it for unique qualities that might deepen our understanding of other planetary systems. The rumor of 350 unknown objects. Almost immediately after news about 3I Atlas spread, sensational claims surfaced about hundreds of unknown objects suddenly appearing nearby. Specifically, a figure of 350 objects lurking close to this interstellar visitor. Such headlines spark excitement and concern, but require a careful fact-check. NASA, the European Space Agency, and many professional astronomical observatories systematically detect and track objects in the solar system, including asteroids and comets. No scientific observations or credible data validate the claim of hundreds of unknown objects clustering near 3I Atlas. In fact, the observations clearly show 3I Atlas traveling alone on its solitary voyage through space. Such claims likely stem from a misunderstanding or an attempt to generate viral misinformation. What do observations really tell us? From the ground, massive observatories like the European Southern Observatory's Very Large Telescope in Chile provided sharp imaging. From space, NASA's Hubble Space Telescope and the newer James Webb Space Telescope, JWST, captured light across a wide spectrum. Together, these instruments gave scientists both detailed imagery and chemical fingerprints of the comet. The pictures showed something classic yet unusual: a small, active comet wrapped in a glowing coma. The coma forms when ice near the comet's surface sublimates, turns directly from solid to gas, releasing dust and vapor as the sun's heat reaches it. The nucleus itself is tiny, estimated at less than 1 kilometer across. But measuring that size is no easy feat. The nucleus is hidden inside its own bright shroud, and astronomers must rely on brightness models and indirect calculations rather than direct imaging. Even more compelling were the spectroscopic analyses. When light passes through the comet's gases, it carries unique fingerprints of the elements and molecules present. These spectra revealed a composition that immediately stood out. Alongside common gases like water vapor, carbon monoxide, carbon dioxide, and cyanide, astronomers detected something rare: atomic nickel vapor. This was a startling result. In comets within our solar system, nickel is generally locked away inside dust grains or rocky particles. It's not something that typically escapes into the coma in gaseous form. Yet here was a comet from another star system shedding nickel atoms into space. The absence of a corresponding iron vapor signal, normally expected alongside nickel, only deepened the puzzle. The significance of nickel vapor. The nickel detection wasn't just a curiosity, it was a genuine scientific anomaly. To understand why, imagine the chemistry of most comets as frozen snapshots of their birth environments. These dirty snowballs preserve ices and solids from the earliest stages of planetary formation. By studying them, scientists essentially peek billions of years into the past. So what does it mean that 3I Atlas is venting nickel gas? Researchers suspect the culprit could be a volatile molecule known as nickel tetracarbonyl. This compound forms when nickel binds with carbon monoxide. It is rare and fragile, but under the intense solar radiation near perihelion, such a compound could break apart and release free nickel atoms. The idea that such exotic chemistry exists in this comet's makeup suggests that 3I Atlas formed in an environment chemically distinct from our own solar system. Perhaps its home star system had unusual distributions of carbon monoxide, pressure, or temperature conditions that allowed such compounds to form and stabilize. Adding to the intrigue, the lack of detectable iron vapor points toward a compositional imbalance we don't often see. In solar system comets, nickel and iron typically travel together in metallic grains. Here, nickel seems privileged, hinting at geochemical processes foreign to our local neighborhood. This single detection, confirmed independently across observatories, opens a cascade of questions. How diverse are star systems when it comes to building blocks? Could interstellar comets carry exotic compounds never found in our own? And if nickel tetracarbonyl is really the source, what does that tell us about the stability and chemistry of such molecules in deep space? The comet's composition and physical traits. Beyond its chemistry, 3I Atlas presents a number of fascinating physical traits. The comet's coma appears slightly reddish, a coloration consistent with dust particles reflecting sunlight. This red hue echoes what astronomers saw with 2I/Borisov, the previous interstellar comet, suggesting that the dusty mantles of interstellar comets might share some broad similarities. At the same time, 3I Atlas has shown itself to be unusually rich in carbon dioxide compared to water ice. That balance is flipped for many solar system comets, where water is the dominant volatile. This contrast alone marks 3I Atlas as chemically distinct. As it travels toward perihelion, its closest approach to the Sun, expected on October 29, 2025, at about 1.36 astronomical units, scientists anticipate its activity will intensify. More sunlight means more sublimation, more dust and gas released, and perhaps sudden outbursts. Outbursts occur when new material is exposed on the comet's surface, creating a spike in brightness. If that happens, telescopes will get a better look at its chemistry and structure, and astronomers might confirm whether other rare compounds are hidden within. Another noteworthy point is the comet's stability. So far, unlike some comets that fragment as they heat, 3I Atlas has remained intact. Its nucleus may be small, but it appears cohesive, suggesting a solid internal structure rather than a fragile rubble pile, bridging toward distances, myths, and the future. All of these findings reinforce that 3I Atlas is not an ordinary comet, nor is it anything artificial or threatening. The nickel vapor explains the metallic headlines, but the truth is rooted in chemistry, not alien engineering. Still, the combination of mystery and rarity has fueled online speculation. Claims have circulated about dangerous close passes to Earth or clusters of hundreds of objects around it. These need careful debunking, which we'll cover in the next section. But before that, one key point is clear. The science so far paints 3I Atlas as a natural interstellar object with unusual but entirely explainable properties. Its distinct composition is a gift to planetary science, a cosmic sample from a star system we'll never visit. Every observation enriches our understanding of how diverse planetary systems can be. And as the comet approaches perihelion in late 2025, astronomers will be watching with every instrument available, eager to capture more data before it fades back into interstellar night. How close does 3I Atlas get? One of the most common misconceptions is that 3I Atlas poses a risk to Earth. In reality, its trajectory has been calculated with precision, and the comet will remain comfortably distant throughout its journey through the inner solar system. The closest approach to Earth will take place on December 19, 2025, when 3I Atlas passes at a distance of about 1.8 astronomical units, AU. Roughly 270 million kilometers. To put that into perspective, this is more than 11 times the distance between Earth and the Moon. At such a range, the comet is far beyond any possibility of collision or significant gravitational influence. It will simply be another faint traveler moving across the background of stars. Interestingly, Mars will experience a closer flyby on October 3, 2025, when 3I Atlas comes within 0.19 astronomical units, or around 28 million kilometers. While closer than the Earth encounter, this distance is still equivalent to more than 70 times the Earth-Moon separation. For astronomers, this offers a convenient opportunity. Spacecraft orbiting Mars may have a clearer vantage point for observing the comet, supplementing data collected from Earth-based telescopes. In short, while interstellar comets always spark curiosity and caution, 3I-ATLAS is no threat to Earth or Mars. Its passage is a reminder of how precisely astronomers can chart the paths of such rare cosmic visitors, debunking the 350 objects claim. Alongside discussions about its metallic nature, some corners of the internet have circulated claims that 3I Atlas is accompanied by hundreds of smaller objects, sometimes cited as 350 bodies or more. Such assertions may sound dramatic, but they collapse under scientific scrutiny. Modern astronomical surveys monitor the skies with extraordinary sensitivity. Instruments such as Pan-STARRS, the Vera C. Rubin Observatory currently preparing for operation, NASA's Near-Earth Object programs, and radar facilities track even faint, fast-moving objects. If hundreds of smaller companions were traveling alongside 3I Atlas, they would produce unmistakable signatures in the data. A sudden apparition of so many bodies would rank among the most dramatic astronomical discoveries of the century, impossible for professionals or amateurs to overlook. So where do such claims originate? In many cases, they stem from misinterpretations of telescope images, where background stars or detector artifacts are mistaken for real objects. In other instances, the source is simply fabricated social media stories designed to generate clicks. The reality is far less sensational, but far more scientifically rewarding. 3I Atlas is traveling alone, and its study focuses on its unique chemistry and structure. The lesson here is one of scientific literacy. While it is natural for the public to be fascinated by interstellar visitors, distinguishing between evidence-based reporting and baseless speculation is crucial. By carefully evaluating sources, astronomers and enthusiasts alike can prevent the spread of confusion. The science behind comet observation. Beyond the rumors, 3I Atlas provides an extraordinary scientific opportunity. Comets are often described as time capsules of the early solar system. Their icy nuclei preserve chemical compounds from the environments in which they formed. When comets approach a star, heat causes these ices to sublimate, releasing gases and dust that can be studied through spectroscopy. Interstellar comets take this principle one step further. Instead of carrying the history of our own solar system, they provide chemical records of other planetary systems across the galaxy. The outgassing of 3I Atlas allows astronomers to analyze molecules and metals that condensed around a different star, perhaps billions of years ago. One particularly intriguing finding has been the presence of nickel emissions at large distances from the Sun, where temperatures are far too low for such metals to vaporize under normal conditions. This unexpected result suggests either unusual chemistry or physical processes not yet fully understood. In essence, 3I Atlas is rewriting parts of the textbook on cometary science. These discoveries feed into broader questions. Are the building blocks of planets similar across different star systems? Do certain chemical signatures appear universally, or are they unique to each stellar nursery? What do these interstellar travelers reveal about the diversity of galactic material? By answering these questions, astronomers not only learn more about our place in the galaxy, but also gain context for the search for habitable worlds. Continued monitoring and research. The scientific value of 3I Atlas has ensured that it remains under close watch by the world's most advanced observatories: NASA's Hubble Space Telescope, the James Webb Space Telescope, JWST, and the European Southern Observatory's Very Large Telescope are all collecting data across multiple wavelengths. Ultraviolet observations probe the composition of gases escaping from the comet's nucleus. Infrared imaging provides insights into the thermal properties of dust grains and ices. Meanwhile, visible light spectroscopy helps characterize the comet's coma and tail. Together, these datasets create a comprehensive picture of the object's physical and chemical state. The monitoring will continue as the comet nears perihelion, the point in its orbit closest to the Sun. Each stage of its journey offers a slightly different vantage point, allowing researchers to track changes in activity levels and compare them to predictions. Such systematic observation is essential. By understanding one interstellar object in detail, astronomers can develop models to interpret the next, making each discovery more scientifically efficient. The future of interstellar object studies. 3I Atlas is not an isolated case, but part of a growing field. Its predecessors, Oumuamua 1I/2-017U1 and Borisov 2I/2019Q4, revealed the extraordinary diversity of interstellar bodies. Oumuamua with its elongated, tumbling shape and unusual acceleration, and Borisov with its textbook-like cometary behavior. 3I Atlas now adds its own mysteries, particularly the strange metallic emission signals. Looking ahead, astronomers expect such discoveries to become more common. The Vera C. Rubin Observatory, with its powerful survey capabilities, is predicted to detect dozens of interstellar visitors each decade. With each new arrival, scientists will refine their understanding of how material is exchanged between star systems and what that means for galactic evolution. The implications stretch far beyond cometary science. Every interstellar object is a piece of a distant planetary system ejected long ago, traveling the galaxy until chance brings it to our doorstep. By studying them, humanity gains a rare glimpse into the chemical and physical diversity of other worlds, information otherwise unreachable without interstellar travel. Conclusion. From its distant, harmless flyby of Earth and Mars to the debunking of wild rumors to its role in expanding our understanding of cosmic chemistry, 3I Atlas is a scientific gift. It challenges assumptions, fuels new models, and strengthens the case for expanding observation networks. While sensational claims may grab headlines, the true story is even more compelling. We are witnessing the passage of a fragment of another star system, carrying secrets billions of years old. With each observation, astronomers move closer to answering fundamental questions about how planets form, how materials are distributed across the galaxy, and ultimately how unique or common our own solar system may be. Though sensational headlines claim otherwise, 3I Atlas remains a lone interstellar comet, a remarkable visitor providing extraordinary scientific opportunities. The idea of 350 unknown objects nearby is pure fiction, not supported by any credible evidence. By following NASA's and other agencies' research, we gain accurate, awe-inspiring insights into the universe. Stay curious, stay informed, and keep following for more cosmic discoveries.